The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello, everybody. Thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kīlauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS-HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dan started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally got.
Aloha, everyone. Welcome to our Hawaiian Volcano Tracker for December 11th, 2025. I'm geologist Philip Ong, here with Mr. Dan DuPont and Mr. Lou Atori. We're here to track Kīlauea's latest episode, number 38, which occurred last weekend. And that'll be the main topic of our update to you guys today. How are you guys doing, gentlemen? Dane, how are you?
Oh, doing pretty good, yeah.
busy weekend and just been having a bunch of people come through Tracker on the Hawaii Tracker Facebook and share a bunch of content still coming through from people's backlog from this episode.
Yeah, how about you, Lou? How is this episode for you when we can hear you?
I'm just going to throw this out there for everybody because it's going to be the topic of conversation at some point. We are all deeply depressed that the V3 camera is no longer available. It's coming out early. It's coming out early. A heck of an episode and a lot to talk about tonight. So let's get into it.
At least it went out in a blaze of glory, you know.
It sure did. Right.
Yeah, and no people next to it, which is the even better part. It did its job admirably.
Yeah.
We'll probably miss it the most before the next episode. Right now, we're going to recap its glory, its last hurrah here. So, all right, let's get into it, huh, gentlemen?
All right.
As usual, Dan and Lou will be collecting questions, leading discussion on the chat. So let them know if you have anything to drop in for us to discuss. And anything else? So let's get into it here. All right, let's rearrange our screen, get everything set up properly. And all right. Hello, everyone. This is our Hawaiian Volcano summary for December 11th, 2025. Following a 9.5-day pause, Kīlauea's 38th episode of its ongoing summit eruption began this past Saturday, December 6th at 8:45 a.m. with vigorous fountains that lasted just over 12 hours. The precursor activity began about 20 hours earlier with periodic overflows from the north vent, which I'll show you guys here, turning away from our live view to our view from the KW camera, which pans the crater floor. So there you see those first precursor lava flows, which then led to the onset of vigorous fountaining from both the north and the south vents initially, and then later to just the south vent itself. So that moved kind of fast. I'll just play it one more time to show you the progression of the first overflows. At first, we have a triple vent from a double opening in a north vent and a south vent combined. And then we have a burst of a surge of lava from the south vent, which then reconfigures the situation, inclines the south vent laterally, and goes and takes out the V3 camera and S2 cameras. So we'll get that here in just a second, but first a view from the reverse angle from the B1 camera on the eastern side of the crater, showing the switchover in fountains from triple to the single, and lava flows that came across not quite to the eastern edge of Haleakala crater floor, but covered roughly 60% of that area. Looking at the V1 camera, here it is, those first overflows and that burst of lava with continuing movement of the deposits for several days after the episode ends. And switching to the V2 camera now, and we can see this further back view, and you can see the configuration of those fountains there. And I'll pull us back and just pause it here so you can get a view of the triple fountains there, and then the inclined fountain with the north vent shutting off, and just the south vent fountain moving along there. So that's the V2 camera. And unfortunately, on this left side of the image here, where this fountain of lava is landing, right in this area over here, is where we have the location of the V3 camera. So here it is, a very slow recap of the last images it captured, the overflows and leading to the onset of fountains, and then the directed fountain coming right out of camera before it cuts out. We'll have more information and details on this in our full update. Join us there if you're interested in that. But to show you guys that final sequence here, there is the surge of lava that comes through and bursts through the base of the south vent that the USGS describes as an explosion. That is later followed by an obstruction of the vent, the inclination of the fountain, and you can see here these pieces of tephra and clots of lava raining down right across the front of the camera before it goes offline. We have a map released from USGS of the tephra fall from this episode, which for the most part went to the southwest into the closed area of Hawaii Volcanoes National Park into the Ka'u Desert. However, the eruptive plume rose up to 20,000 feet or 6,000 meters and then blew to the east and reportedly dropped baseball-sized pieces of verticulite to the east along the chain of craters road here. So there was impact all around, but nothing too dramatic outside of the camera itself, which if we zoom in here, we can see the location of both eruptive vents on the southwest wall of Hawaiian crater, and the V3 camera here at the end of the former crater rim drive where it's truncated, having collapsed into the crater in 2018. They've drawn here a 1 mile radius from the vents, so you can see that here we are within that half-mile range or so from the vent where the camera was wiped out. All this happening within Hawaii Volcanoes National Park in a closed area with no increased lava threat to people. The main threat is still the gas and the fog, which we'll get into here in a minute. But to recap the statistics from this eruption, the highest fountains from the south vent before it became inclined were 1,200 feet high, 370 meters. Even once it became inclined, it was still hitting 1,000 feet, 300 meters. So it was quite an outpouring of lava. If we look at the volumes, this episode 38 put out the second highest volume of any episode in the entire year of eruption thus far, trailing only episode 3, which itself took 8.5 days to accumulate that total. So a much larger discharge rate, rate of lava output, which you can see here, higher than 37. The fourth highest eruption rate of the year, just behind episodes 34, 35, and 36, which the 3 of those had both north and south vents active the entire episode. And we just saw how in 38 we had just the south vent active for much of that duration. So an increase over the previous episode, but not quite to the same standard as we saw 3 to 5 episodes ago. Our ground monitoring instruments are showing the typical signs of recovery following episode, leading us to believe there will be another episode, number 39, to come. You can see from this tilt plot that we had a slightly shorter run up to this episode and a larger than usual outpouring of material. And on top of that, a few other distant earthquake signals also showing up here. But the USGS is using that inflation rate to forecast the likely window for the next onset to be between December 20th and 30th there from today's daily update. So looking at the VOG forecasts, even though the main episode is over, we have continued lower level degassing from the vents. And combined with Kona winds since the start of the week, we have quite a bit of VOG impact around the summit area and to the northeast around Hilo, as well as the typical southwest areas. So a much wider footprint of volcanic emissions on the ground today and for the next couple of days. Looking at our Purple Air Citizen Science Monitoring Network, we can see increased values, especially around the volcano area and to the northeast, all the way into Hilo, but as well to the southwest and Pahala and Ocean View as well. A couple of snapshots taken by the satellite of this SO2 emission plume, tracking it from the summit area upwards and then blowing east before hooking to the south. And then the following day, it's redistributed back across the island in an upper atmosphere. So there's plenty of VOG out there in the upper atmosphere as well as at ground level. Finally, looking at the earthquakes for the past week, we have continued low-level activity. We have some events underneath the summit and one magnitude 3 south flank event, a little to the west of where we had the big event last week, but the same process of this movement of the south flank accommodating expansion and growth of the volcano at the summit. Earthquake counts are still low within the background value ever since the onset of eruption on December 23rd of last year. So that's the current status of earthquakes, and we'll wait the next episode. And that's your Hawaiian Volcano summary for this week. So with that, we'll switch to our hazard, our main hazard being the gas. And I'll start off by showing you guys the view from the K2 camera. And so there is our onset of the episode. And you can see how mostly the gas is blowing over in that direction. But as we come into Monday, Tuesday, Wednesday, you see the gas is blowing over here now and towards the camera, and it's really flopping all over the place in this view. And that's the impact of a VOG that we're seeing here after the episode, mostly during the following week, this past week that we've that we're currently in. So that's the K2 camera. It would have been a great place to see that episode. And if you look at that map again, this is the closest overlook to the vent itself, even if it doesn't have a straight line of sight of the entire caldera floor. Moving to the KP camera, let's rewind this. This is the one on the side of Mauna Loa, looking to the south. And so there is Kīlauea with its small little gas plume back on the 4th, couple days before the episode began. There was quite a lot of weather coming through, some big clouds. Can see some glow. There's our big plume, but you can see it's obscured. Gets illuminated a couple of times during the night, but otherwise we have weather stocked in. I'm going to shorten the nights here for the rest of the animation, but you can see that there is still continuing gas coming out of there, even in the last few days. And now we can see it actually blowing off in that direction towards Hilo. So that is the KP camera on the side of Mauna Loa looking to the south. Let's keep going up Mauna Loa. Let's go all the way up to Mauna Loa summit to that Mauna Loa camera. Let me put this on loop. Let's play this. There's Mauna Loa summit. There is our big gas cloud from the volcano. This over here on the right is just regular weather. But you saw it burst through there. Right? And so this camera is at about 14,000 feet elevation. That's about the eye level down in here, more or less. Right? So when we see this burst all the way up, this is that 20,000 foot height, 6,000 meter height the USGS is describing was evident on the satellite views there. Really impressive. And besides that, they mentioned how most of that fog blew to the southeast, which would be in that direction. You can see that trail of it going off there. But you can also see there's a second wisp of the gas that's blowing across Mauna Loa summit itself. Like right here, you can see all this stuff right here in the foreground, coming right at the camera in some ways. Right? So it really kind of split and diverged, with a bulk of it going to the east, which is where many of our residents and followers live. So that would be the focus, looking up and looking at a dark sky and wondering if there's Pele's hair falling down in any direction or not. So that's the Mauna Loa summit camera. Let's go on to the Mauna Kea summit camera. A view of it. So there is our cloud. We have much more weather and a saddle obscuring this, but you can see it over here as well. Clears up a little bit at night. Let's loop it and zoom in. Maybe it'll let me zoom in. There we go. Yeah, so a lot of obstructions, but you can get these glimpses from time to time of that. You can see where the base is and the height of that plume, and you can see in this view how it really comes up and then turns the bulk of it in that direction. I'll leave this outline here so you can see it fill that hole right there. There it goes. It's a really fascinating pattern there. But as we're focusing on a VOG here at ground level, I thought I would show you this view of the B1 camera. And what I've done is just go back for the daytime views for the whole last week. So here's our day of eruption. You can see how the gas is blowing over there. It's really coming up and over the camera in this direction. But here we are on the 8th in the morning. Our gas is still blowing trades, but that's when things change as on Monday. You can see here the plume rising. Now it's flopping around. It's going to start blowing off in this direction towards Hilo now. And this was really clear on this view this week. So I thought this would be a great one to show you how it's really put this VOG towards all these overlooks in this direction, right? With the Huna site around in here, the Kīlauea overlook site somewhere over in here, the steam vents over here. So when we have the gas blowing like that, then it can be reaching many of those areas. So looking at the VMAP, VOG Measurement and Prediction Program out of University of Hawaii at Manoa, looking at their VOG dashboard in particular. Here it is. We'll start off with the pure SO2 pollutant, the pure gas that comes out of the volcano before it reacts with all the water vapor and assisted by sunlight to create the sulfate particulates. So that pure component, you can see, is closer to the source here around the volcano area, but you can see it also is drifting to the northeast, drifting to the southwest, occasionally to the north. So it's really flopping around in every direction there with these changing winds. And that's that pure, but looking at the more evolved component, you can see that there's a larger footprint and a longer lingering pattern. It reaches all the way up here to Kamakua, almost to Waipio Valley, in fact. You can see up here. So that is the current VOG forecast. And even though we're in between episodes, this may be more impactful today than it was last weekend because of the wind directions here. And that's what we unfortunately have to expect here during our winter months when we have this variable wind pattern. And we're lucky to have come out of last winter when this eruption really began, and enjoyed the summer with not a whole lot of Kona winds. And here we are back. It's lasted long enough that we're back at that same part of the cycle again. So looking at our interactive maps, monitoring maps, starting with the state of Hawaii air quality data. If you look at this, everything is in the green, but there are some high numbers in here. So for example, here is Mountain View. Hasn't hit the yellow today, but you can see it's skirted pretty close for much of the day. Likewise, let's look here at Hilo itself. And Hilo actually did make it into the yellow earlier today, around the middle of the day. And so that's some examples that direction. Pahala, on the other direction, you can see also came close, but didn't quite reach yellow. And further down, let's look at Naui, who's a little closer to the coast, doesn't always get it as bad as Ocean View, which you can see also, because of the variable winds, is getting it a little bit easier than usual. During the trade wind patterns, they usually get most of the volume only going to that direction. So that's the state of Hawaii site. And some examples of those plots. Let's check out Captain Cook. Also a little bit lower there. So moving on to the purple air, just to show you guys a little difference. As I check this throughout the day, sometimes those other websites don't show the resolution and time, or they don't show these values going to the red or the yellow because they seem to average over longer periods of time. So it doesn't always reflect what you might be feeling on the ground, in my experience, which is why I particularly like the purple air, where there are more data points and they're distributed all across. Right? So, for example, this site here at Kulani, north of the national park, there you can see it went past the green, past the yellow, past the orange into that purple. And you can see very high values there. These are particulate readings, PM 2.5, right? So this is that SO4 component. Right there. So you can see quite a bit in a variable. It comes and goes and comes and goes, but overall something to be really wary of in that area. There are some other sites that when I checked this earlier today, let's see how much I can zoom in here. What's going on here? Let's try this one. All right, so this one is Hawaii Volcanoes Observatory Portable. This may be over by the military camp, or I'm not sure exactly where in that area on the north rim, but you can see here, depending on the wind, these spikes coming in over and over and over again, from the yellow into the red and the purple, back and forth today, and you can see yesterday as well. So that's the pattern we've had here. Those are the ones closest to the summit, to the emission source. So let me find somewhere else. Let's look at Hilo, for example. It's for comparison. And so there you see a little bit more resolution and time on the data as opposed to what we saw from the state website, which just showed us bar graphs for every 15 minutes, right? Showing us how it's changing every 10 minutes here. Apparently. So, okay. We could keep going through, but I think you get the pattern here. It's similar in Ocean View and elsewhere, right? With, especially if you see that in Hilo. Maybe we'll add one more here in Puna, Ainaloa, which doesn't usually get these signals. So there you can see the plot rising into the yellow several times over the past couple of days. All right, and so finally we'll go to the Hawaii Volcanoes National Park site, which if you look here, you see it shows everything in the green right now. But if we go to the charts, we do pick up some of even in this average data at the Art Center, at Wikahuna, SO2, and particulate matter at the campground, SO2, all the way by Ocean View at Kahuku. Plenty of SO2 coming through there as well, depending on the direction, right? It's just really going everywhere, right? Northeast and to the southwest. There's a steam vents, got worse SO2 this morning. So certainly there have been impacts. Kanakakoi spiked yesterday morning, both in particular matter and SO2. So certainly there are impacts out there more so than during the summer months. And even if you're visiting now without the fountains going off, then it's still something to be aware of, especially if you're someone with respiratory sensitivities. So check that out, follow park guidance, and yeah, go from there. So turning to the mounts project here, this is the catching all the satellite data. We're going to look at this filter for SO2 here, just for the last few days. So back to the 5th. Oops, snapping to that view here, but let's come back to the 5th here, where we have just a little bit of emission coming out, drifting south. The 6th, it's blowing a little bit more to the west. You can see this variable nature of dispersal. Here's a 6 where we have our big pulse of eruption. The source here, here you can clearly see that even though there is a lot of material going east and then turning south, there is also this wing to the west, right? This is the one we saw coming up to Southern Mauna Loa as well, which would be right around there. So that's the first day. And then the second day, you see that material distributed differently across the atmosphere over the island. And so this is way, way up there. The satellite's picking up the entire atmosphere, and so we're looking at separately of what's in the high atmosphere as opposed to what's on the ground, just so you can have some idea of where it all went. And so then, since then, we have lower level dispersion to the south and west on the 8th, but on the 9th, it seems like it's going more to the north. And here we are, most recent capture, pooling around the summit area there. So zooming out to the windy.com SO2 layer, here is in red that SO2. So here is that band that went east, turned south. You can see now it's pooled over here to our south and east. But also we can also see this western wing dispersing to the southwest as well. So it's interesting to see that you actually can see this at this point in time, only a few days afterwards, before it's mixed up too much here. And so that's our signature contributing to this global SO2 volume that's circulating much of the northern hemisphere at this point in time. And so that's our hazard summary. And all I can say about the gases here right now. So let's move on to our observations. And starting with some time lapses, I'll play back this full time lapse from the KW camera with those first overflows there. We'll go a little slower through it this time. You see that those first few were pulses before we have a longer gap. And then around 3:45 in the morning, we have the continuous diffusion beginning, ramping up to vigorous fountains at 8:45, switching to just a south vent by, what was it, 11 o'clock? By 12 o'clock. And then pooling lava all across the crater floor, including in this central pit where we've seen subsidence and other pooling and other interesting things happening right through there. So then moving forward through Sunday, you see there's some rain comes through, just a little bit of glow still on the floor. You don't see as much there now, but if I zoom in, you can actually see that this backflow is still moving. This is the 3rd day now after the eruption episode has ended. And so continuing movement there. Now coming to Monday and Tuesday, we'll see the wind change, and we really can't see any more of the patterns. I think this is coming to a halt, but we don't exactly see it stop because here comes the VOG for the most part across our field of view. The other interesting thing to note here is that we've had several cold nights up here at the summit. So you see a lot more of these gas vents on the crater floor in those early morning hours, especially. You can see it there. And a little bit more. Not quite there, but yeah, right in there. Some interesting fuming on the crater floor there. So that's the really great time lapse of this fountain and flows across the crater floor. And I think we got to the end of that one there. So the same view, a little quicker in a thermal camera. And there are those first few pulses, continuous diffusion, sustained fountains, flows across the floor, and overturning in that pooled pond area, with movement continuing for many days of that lava pile that was under the south vent fountain. Just to show you, in the last couple of days, things seem to have halted. This camera is nice because it can see through all of that fog and fume and show us those little details when other cameras cannot. So let's turn to the V1 camera next. Here is that view of the spattering, the gas pistoning with those first few overflows the night before. And here comes the action with overflows becoming continuous. Here come our triple fountains. South vent takes over, north vent dies off. South vent subsides a little bit, backs off, doesn't die off though for a while. And once it's over, then we still see movement of that glowing pile of rubble for several days here behind the vents. Pretty fascinating. Another interesting thing to look at over here is it's hard to see the before view of this, but let me see if I can catch a frame of it over here. This whole back wall over here, it's hard to see right where the fountain is falling. You really can't see a lot of through all that dust that's being churned up, but when it's all over, you can see here there's this little landslide feature right over there that may have been associated with all that material falling on top of it, and I'm not exactly sure there, but yeah, that does appear behind all the from behind all the fume and dust at some point there. So yeah, there it is, still moving, still glowing. Winds changing, blowing the fume back across our field of view here, just like at the KW camera, which is right next to this one, in fact, right? Just different purposes for those two cameras there. You can still see glow, still moving. Look at this, we're on Monday now. And pretty fast movement through that central channel right through there. Still seeing glow here between Monday and Tuesday night. All the way up here we see glow in these cracks. Really interesting to see this whole area still continuing to creep and slump under its own weight with that still fluid lava inside of it that's going to all piled up and was able to insulate itself and keep that center part fluid enough to allow this process to happen. Excuse me. So that's the V1 camera. Let's show you again the K2 camera. Let's show you guys just the eruption. So this is a similar view if you were visiting in person. This is the best you could do rather than being a camera, is approach this overlook. You can see all these people enjoying that view down there with the fountain.
Hey,
You can even see some little flows down here at the base.
Hey, Phil.
Now that lava shield has raised up enough. Sorry, someone saying something?
Yeah, it's me. Breaker 19.
Sorry?
Can you hear me?
You're kind of quiet. You're kind of quiet.
Yeah, I'm here now.
Am I there?
Yeah, there you are.
Oh, there you are.
Okay. Hey, did you on that video on that camera? Did you notice the amount of people difference up there versus all the past episodes?
Yeah.
I mean, double to triple than what are usually up there.
Yeah, and even still, the overlook is not full.
Right, not even close.
If you look at this, right, you can see the benches, 3 benches here are all empty. No one's even standing in them. They used to be a popular thing in the past. Like, the place is so crowded, people stand on the bench to see over people's heads in front of them. So yeah, it's probably the most intense experience. How close you could get, how loud it is, how you can just feel the whole vibrations through your whole being there. But the real drawback is you can't see the whole crater floor from there, right? And so that's why people like to go other places to get the broader view. And if you're lucky, maybe you can go more than one place. But With the parking issues, then that might not be the easiest thing to do. So kind of walk around, see it from all the different angles. Yeah, good point, Lou. Yeah. So there's all the people, and I'll just leave it at, I guess we can let that play through. Even by that evening, people actually clear out quite a bit. It's looking empty now, even as eruption is still going. And there it finally ends. And we can't see much anymore there, but you can actually see there's a little bit of flow visible from at least the tower where this camera is placed. It might be different on the ground level right there. So moving to the V2 camera, this is from the Volcano House area. So it's a longer shot. You have more weather in a way, a lot of times. So those first few overflows before this sustained activity begins here, leading to these fountains. We'll pause it right there once again. Look at that combined double north vent and inclined south vent. And see how tall this thing is reaching. And they reported this to be 1,000 feet high still, 300 meters at this point in time. And before that, when it was more upright, they were saying it was 1,200 feet. So it's not a record, but you can imagine, like, if this wasn't inclined, it could easily be matching the record we had from 2 episodes ago, where it was also the south vent that was really skying the lava too. So we'll keep this going there. And there's a V2 camera with the V3 camera somewhere over here in this fallout zone. You can see the fountain height drops off several hours before it ends. And then here in this foreground, we see this is that perched area that overturns. And over here, we can see that debris flow, lava flow of the secondary lava flow from all the fallout from the fountains. When it's not too foggy, we should say, right? Which is an issue from this direction here. A little bit of glow at night. We're zoomed in, so we're not seeing the broader edges of the crater there. There are reportedly some landslides occurring somewhere in this back area as well, but not so easily to pick out through all the fume and darkness here. So that was the V2, and so here is the V3 one more time. I'll just play the time-lapse version from earlier that morning with the spattering, the fountains, and pretty quickly early on in the episode, the camera gets knocked out. But here you can see this snapshot of the south vent fountain becoming higher and just starting to incline towards the camera here. Double north vent fountain there. And there earlier in comparison earlier, where they're more equal in height at around 500 feet or 150 meters or so for that first hour of eruption or so. Okay, we'll look more at this sequence from the cameras with Lou in a minute here. So I'll just move on from the V3 from now. And just also point out that the S2 camera was also next to the V3. The V3 is getting all the attention. The poor S2 camera is also no longer with us. It wasn't a live stream camera, but it was the longer lasting of the two. And so here we see that view from the S2 camera itself too. Very similar views. The S2, let me remind you, was the one that was deployed at Nepal crater during its 2024 eruption in the East Rift before it got moved back over here. I think before Nepal, it was deployed in the Southwest Rift Zone. So this camera's been around. It's done its duty before getting retired by lava here. And also worth mentioning, the V3 camera itself, if you recall, was once the B2 camera, whose casing was melted by the lava flow down on the edge of the crater floor. So the camera survived that one, but it looks like Pele really wanted to get that camera. And so on the second attempt, she succeeds, and no more of the S2 or the V3 cameras there. So more about this here in a minute, but let's continue finishing the time lapses. Starting with this B1, there is the back wall with the vents putting out those precursor lava flows. Here comes the main fountains, the flows reaching across the crater floor. You can see it doesn't quite reach the eastern edge, but it does go a fair distance. And there is a branch through the center here as well. It doesn't quite get to the middle of the field of view here either. So that's the B1. But much more interesting than that is the daily views from the B1. So what I've done here is starting the day of the eruption itself. So just Saturday through today, one image from noon each day, and sped up to show you guys a sequence, right? So as usual, you can focus maybe first on the changes around the vent. You can see it looks like the ground raises in here quite a bit, and we see this flow of material that happens for days here afterwards. But more interesting is looking here at the center of the crater floor. You guys can see that little wiggle, right? This little wiggle is just the loop restarting, and it restarts the day of the eruption. So what you're seeing is when eruption, the day after the eruption, the whole ground is raising up through there, right? That's the sequence. So you can see it. So it's not as confusing without the loop. Lower and higher there, right? And so there you can see it's happening all in the center, all the way in this eastern part. You can see it's really bulging through here. This piece right here is not moving, but almost everything else in this frame is. You can see the edge of it right there. You can see it actually swelling up like it's inflating. Right? So there's no flow that reached this area. You can see the edge of the flow that came right over there. That's the furthest reach of the episode 38 flow across the middle of the crater. On the far end, it's about in here. Right? So you actually can see no lava reached here, but yet the crater is undulating because lava was injected beneath it. And I say undulating because look at this section right in here. There's one, it almost looks like it's a wave rolling across the surface here. Really fascinating. And this is rising while this is falling, while this is rising, while this is falling. It's really some complexity happening as lava is injecting beneath the crust out here. So we'll continue the examination all the way to the eastern edge here. See, all the way to the eastern edge of the crater, not quite this thinnest lip here at the very far side, but you can see a whole bunch of movement right through here, especially too. And all the way to the back. It's really quite impressive, quite dramatic. And remember, if the camera's picking it up in this resolution from this far away, if you were actually there in person, it'd be probably a substantial raising of the ground, right, compared to the size of a person. Still very impressive to see this here. So the question really is, like, how much is the lava really injecting beneath the crust, and how much could it be the weight of the lava above it rolling, perhaps trapped lava underneath all these layers towards the eastern edge? I'm still not sure about whether either of those can be eliminated, right? It does seem like there's clearly movement of lava beneath the crust over here, whether it's being injected directly or being pushed from above by all the weight of the new flow. That's really what I'm talking about, the question here. Not quite sure. It might be something to ask the USGS when we see them next, what their ideas might be. So similar exercise, but from the KW camera on that northern side there. So once again, looking at the vent changes, there you see that secondary flow continuing. You can really see this slumping back over here, right? So here is that, if we look at that landslide that I pointed out earlier, that's at the right edge of this whole feature. And I can't really zoom it in any more than this, but you can see there's these cracks opening up back here, an upper part of that slope, and that's what we've seen, where we've seen glow coming from, those cracks here in some of these cameras in the evening time. So you can see it's all sliding down. Here's an old block from the collapse, right? You can see how the stuff's moving down over there and sliding around and flowing out. It's really, really quite incredible. Okay, but back to our undulation of the crater floor. So first thing to note here is this is the area. Once again, I'm starting this on the day of the eruption itself, so there's no time from before the eruption here. So you're really capturing in this pond area right here, how the lava is ponded and then subsiding once again, because that's where it's the thickest area, so it can release the most gas and show the most subsidence. But then further afield, keep it going, we can see crater floor actually can be seen to rise right there, all through here, like all this backside, you can see it rising all through there, bulging upwards, right? All through here, this whole back wall. Here's the edge of our flow on this northeast side, right in there. Maybe it's something like this. Don't really see it. It's maybe the flow is coming rolling across, and that's what's squeezing things up, or it just could be that it's injecting below as well. And that's where this question of what happens in this little ponding zone is relevant, because we've seen this thing drain a full week after an eruption episode ends, and that leads us to speculate whether there might be some drainage pathways, whether it's a network of lava tubes or other conduits that move across, that connect the different sides of the crater beneath the crust here. All right, so let's see, just do one more of these KW ones, and that's what I'm gonna do now. Is I'm gonna go to 2 days from before the eruption, right, where we're seeing subsidence of this area, which you see it here as one of these two halves of this frame. Then it gets flooded with lava, and you can see it starts to subside once again to reform itself. And so this is just a little window into this really unique area that we've seen do some fascinating things over the past few weeks here. And just to show how this is a feature that keeps remaking itself in this area here. Okay, so before we get Lou to jump in here, let me just show you guys some of these highlights that USGS has released from their own photos and videos, starting with episode 38 from December 6th. There's a view taken by Mike Zoller of this combined north vent dual fountain and a south vent spraying all the way to hit the far southern rim of the caldera up there. Here you see some pictures by Katie Mulliken of the tall eruptive cloud, the plume rising up beyond the edge of the photograph here, and how much tephra is caught in that weather pattern, swirling around the edges of that rising cloud. Similar view, but this is actually now in a south rim, noting that in the late morning of December 6th, that would mean, to me, after the cameras were knocked out, right? They decided to approach the area from the southern rim, right? The other end of the road beyond which where the cameras were. And so here you see them walking out in that direction there. And a view from the end of the road, what that actually looks like there. By that point, the north vent fountains were shut off, but you can see this impact, and all this dark material is that dust and ash generated from all those chunks of hot but hardened lava, all is getting crunched in each other and getting pulverized and caught in thermals and blowing everywhere, as well as the bits of lava that freeze in midair and form Pele's hairs or Pele's tears, and all those little bits that can also fly around. Similar stuff is what's collected here in the foreground of the image, in fact. So they got a couple more here. There's another view of that end of the road, but they are also pointing out another tephronado, as they're actually calling it here in their own caption. Since it's over tephra, it's a tephronado. I guess if it's over lava, it's a lavanado. I guess that's how we're doing it here. So there's that. Tall eruptive plume once again. And this is a view of the V3 camera getting knocked out. Let's leave that for now until we get Lou in here. And there is one other video that they posted here that I can share with you. Let's see here. I have a sound comes through here, but there is a roar audible in this video at different points, depending on how close the camera happens to be. So see the fountains there, the impact zone on the southern wall, the ponded area, the rapids into it, rapids out of it. That fall zone as the fountain shifts where it's landing. All these views are taken here from about it seems like the north area, probably a little past Wikahuna, but you can see the fountains moving from right to left. There is a tall eruptive cloud. You see how vertically it's rising straight up there. And there is those bits of tephra swirling in the wind on the edge of the plume. That's a Kīlauea overlook. Well, people get able to see it there. There's the big piece of the old road and the impact zone here off to the side of us getting the crater wall. It's really fascinating to now view from the south as well to give you guys both perspectives there. All right, there's another release from USGS deposits on December 9th. So they actually do an overflight of this. So you see the whole caldera floor up above with the inner crater, which we often refer to as Hale Makma'u, although Hale Makma'u could also refer to the whole larger area. But here is the end of the crater rim drive on the south side where the geologists were just walking to get this perspective. Here you see this dark line, the edge of the fallout zone of Tephra, and where the previous crater rim drive came was something like this. So it was somewhere right in, let me put that back. Somewhere right in here is where the V3 camera was. Didn't put it back far enough. Somewhere right in there. Right in there. Right within the edge of that fallout zone, as we'll see from the map again. You can see both vents still degassing. North vent seems like it's degassing mostly out of the hole closer to the crater wall. We're panning around. Here's this big Tephra hill, the pu'u that's built on a rim. Big pile coming around. Here's the location of the camera, somewhere in there. There's the edge of that little rock slide and where all this debris is coming out, the cracks, which you can see emitting fume from their interior as well. And there is that piece of road on that block of land that's collapsed from 2018. They're still visible off to the side from the other angle now. So yeah, that's the summit overflight video. They have some still captures from that, but back to this image first. This is taken from satellites. It's basically like an INSAR image where they're subtracting before and after the fallout of Tephra. So there's our webcam. You can see the green is where stuff accumulated right inside the edge. If this thing had been just a little further over, then it might have survived. But of course, the easiest place to put it is right at the end of the road. So that's where it went, and just happened to be unlucky in that sense there. Okay, so we've talked about this already. I'll keep it moving. They're down servicing GPS stations on the caldera floor right there. This looks like a down drop block with vegetation on it. A good place to put your equipment. They're sampling the rubbly spatter-fed flow from episode 38 there. There is a 6-foot tall geologist to give you an idea of how tall or how thick these sheets of lava are. We're looking at them from far on a camera, but they're pretty big features once you have a person next to them for scale. There is another view of the overflight, and they do note that during overflight, they did photogrammetry, right? So hopefully we'll get a new eruption map as a result of all that before the holidays here. And finally, we have this series of thermal maps that span brackets episode 37 and 38. So 37, precursor overflows over here early on. I didn't catch 37 as much while it was happening. They caught the aftermath. So there you see the channelized inactive flow on the northwest side and the ponded flow on the east side, both inactive by the time that this image is taken. And then a week later, just after episode 39, you see its channelized flow and events laid out there as well. So one final thing I wanted to mention, I was trying to figure out a little bit about how far, let me pull up this map one more time of the camera and the radius and all that, right? So I went through and I did a pixel analysis of the scale and measured how far it was from the south vent to the V3, and that's where I could come up with this value of 0.65 kilometers or 0.4 miles, something like that. But as part of trying to figure that out, just wanted to point out, I came to look at the USGS map page where you actually can select their instrumentation. Here are their cameras. And if you look here at their views, they actually put, this is not quite correct. It doesn't want to go any further in there. Maybe like that. Okay. And here's the end of the road. We're told the cameras were actually over here at the end of the road. this particular GPS point is inside the crater on a rubble pile. This one too, so that's probably not true. And likewise, if you look at some of the other camera locations, they're a little bit suspect where they're placed. Like over here, these are probably not sitting on a crater wall either. They're probably up here on a rim. So a little bit slight error in the, or lack of precision, maybe we'll say, right, in this data here, that why I trust this particular map and location better there. Let's leave that at that. So finally here, get Lou in here, but just a quick look in at the V1 camera currently as the sun is setting, making it look a little pink there. Gas coming towards the camera again, and can't really see much of the vents. And the V2 camera as well. Come on, there you go. Showing a lot of haze in the field of view here. The VOG seems to be drifting left to right here and making it hazy. All right, there's a lot of stuff that happened in this episode to cover there. Let's bring in Lou. Lou, you got some other observations to share with us?
I do. And it's a good way to segue into what I have here for tonight. We're going to start off with the story, really, of what's been going on is the VOG, right? But there's also the wind that's blowing in. We're changing directions with the seasons. We're normally going east to west. Now we're going south to north. You can see the little, I don't know, Tefrenado in the caldera there, running across the floors off the V2 cam now. Is it Tefrenado or is it Tefrenado?
Tomato, Tefrenado.
Right. The VOG is definitely, you talked a lot about it at the beginning of the stream, and it has been thick. I mean, usually it's pushing Kau and around. This time it's starting to hit us over on the other side of the slope here. We definitely feel it down a little bit. Here's a flyby. USGS-HVO was flying around. They just did a little kind of check something and took off. I pulled that off the cams that happened during the week. There's a time lapse of what we pretty much have been seeing every single morning when we wake up. Just the constant push of degassing going on from both vents, nonstop. The glow, we're only getting out of the V1 cam because V3 is now no longer with us, and it's not enough glow to really push off. Phil, you definitely showed some shots of it, but we're not seeing any other signs of spatter or flaming going on. It's just been, taking its time, doing its degassing, and pushing off of a lot of this right here during the day.
It's easy to look at it. It's like any moment in time, you'd be like, oh yeah, it's gassing. But if you see it, like how much is coming out continuously and billowing all over and over, unending forever.
Yep.
It really adds up.
Yeah. So here's our shots of episode 38 right here. Phil and I were messaging earlier about the third. Phil, how are we classifying the north vent, since it had two spigots coming out of it? It's two vents within one. How are we actually talking about that?
It seems like there's some wiggle room here, right? Just based on how the USGS has referred to it. They've called them subvents, right? They call them two subvents of the north vent. They've called them two vents in a north vent cone, or the north cone, maybe. Maybe those names are changing and evolving as we come along here, but yeah, I think that's about the range of it here. So,
so if you take a look at this, what's going on? Take a look at that, Phil. Maybe you can draw. Can you draw on this screen? You can't draw on this screen.
I can't draw on your screen.
Now, in the middle there, the third vent in the middle, you can see as the south vent is shooting all the way across, that north vent is. You can see the gas pulsing in there and the lava coming up through there. It's definitely changing, shoots up a little bit, drops back down. It definitely had a lot of activity in it, even though it was small. I mean, everybody's eyes are focused on that big south vent arch right there. But that north vent was interesting. It was actually moving quite a bit.
Yeah, fascinating. Look at that, all that ash on the southwest side there.
Yeah.
Oh, there's our burst.
Here's our moment. So I just threw this in here I sped it up. So we've all seen this. It's been millions and millions of views. I think even one of ours has like 800,000. It's just crazy. But I'm going to drop the speed down because that's the moment it gets interesting. You can see it's sitting at this, and we're used to this at some level, not encroaching the camera, but it's there until it isn't, and it's coming. Because we've seen a lot of tephra like this. We've seen this happening over some previous episodes, but right here is what happens. That was that one push that brought it in. Everybody's been talking about the relationship between the north vent and the south vent, how they coexist together. And some questions I saw was with the gas pushing through that north vent in two different subvents in there, and maybe some type of release of a blockage in the conduit could have been that final combination, that the perfect recipe to push it that much further over. Thoughts on that?
I mean, I think there's, I mean, the when we look at the burst here, right, what they call the explosion that sets off this whole sequence of events, it's coming from below, right? It's actually a burst of the magma itself, right? And in fact, when we come look at the text updates later, the USGS talks about their instantaneous eruption rate spiking right around that time, right? So that really suggests it was like that's the fresh batch of pure hot magma actually arriving at the top. And so we've gone through this sequence before, having like overflows and like basically pouring off like the degassed lava. And of course, that stuff's mixing down in a conduit and a vent as well, right? So that can kind of lower your temperature, lower your gas content, kind of puts a little bit of a damper in your fountain a little bit right there, right? But something was different this time, where that big slug was able to come all the way up in its own push. And when it reached the surface, that's when everything changed dramatically, right?
So let me see if I heard that right. That slug was the new lava coming.
That's what I would believe, right? We saw the fountains increase in height, increase the gas content, content. That means that's the hotter, fresher, more gas-rich lava, as opposed to any kind of mixed lava. That's what I would speculate, and
right. And it seems like it's not the first time we've had that type of situation happen, and it might not even be so obvious. But think of episodes where it like didn't fountain that high, and it seemed more sluggish. And then the next one, 1,000-foot fountains again. So like looking back, maybe there's some variation in there. And one thing that strikes me is 2018, going back to that, the pulses and the surges associated with that didn't become evident until about a month after Fissure 8 had been going. Right. Then you started to see stuff start to happen and started to see the pulses and the surge. Before that, it was just, roar like the whole time, just full on. Anyway, sorry, Phil. Go ahead. Right.
Yeah. I feel like there's like a little difference between that lower resource eruption and what we're seeing here, right? Just because of that whole connected pathway and all that. Whereas here it's just like, when do you need to burp? How much gas? And when? Straight up and out, and that's it. There's no complication there, right? So the surges don't have to have anything to do with collapse or transferring distance across the system. It can just be purely a signal of the gas output, which is basically is what brings the hottest magma up. Lou, have you got that burst, that explosion burst lined up somewhere?
Yeah, let me go back into it.
Yeah, my point was more around just as you progress, then characteristics can emerge type of thing that maybe you didn't see.
Yeah. Certainly has evolved, right? I think in 2018 it was evolving towards ending, but that's what my big objection is. I don't feel like that's what's happening here. I don't feel like it's evolving towards ending. I think it's evolving towards being more efficient, where you can have a big slug of gas and hot magma actually shoot all the way up and out in one straight shot somehow. We saw it record heights 2 episodes ago. This is essentially a very similar situation here, and we've seen 3 before that double fountains from both vents shooting extremely high. So overall, much more efficient in getting out, right? So maybe that removes the buffer a little bit, right? So that's really the question.
Now this episode came in the precursory activity. We were at 5 overflows, maybe 6, with 1 or 2 of the last ones at about 2 hours. So based on all of that and how soon after this episode started, the lava or magma that was down below, this moment of bursting was a lot shallower than previous episodes. Would you say?
Yeah, it could be. Yeah, it could be.
Because the 36th, right? We had days of overflows, 4 or 5 days of it.
Right. Yeah,
This
exactly.
one was,
This
one was minimal.
Shorter ramp up, shorter pause, less overflows at the beginning, right? So, I mean, that's really the question is, like what how much is it mixing? Is it not mixing as much? Like, what's the connection between that lava layers under the lake and the main conduit? Those are all kind of questions that these are all giving us little clues, but the challenge is it's a moving target. Every episode it's reshaping and remaking itself to some degree, and so there could be variations that come through as well.
Yeah.
Let me put this video on the screen here, Lou.
Go for it.
So we can talk about this. Burst a little more here. All right. So this is post and tracker in Facebook too. It's just a loop. This is just double speed. And so you're looking at just a crop of that V3 camera there. And here's the south vent fountain coming towards us right here. I think it'll loop back through here in a minute. Here comes the fallout towards us, but oh nope. So there we go. Here is the triple fountain. Look here at the base of this vent. This is what they're referring to as that explosion. That really the surge comes up. It just destroys that south vent cone. Remember, that thing is made of spatter and cinder and just chunks of loose lava that all just happen to be piled on each other. Right? We saw in 2018 a similar thing, right? Where we actually saw lava trying to squeeze out the side of the cone, making a little fissure. That's something that's not uncommon in these eruptions as well. And we've seen that at Pu'o'o before, where lava leaked out from the base of that cone, and back in 2014. But this really just shows you the force of that surge that came through to burst out and really destroy the vent there. So that's the first thing that happens, is that burst from below. I don't know if you have a video of the V2 where the fountain where this moment also happens, where you see the fountains go from triple to 1 tall one and 2 short ones, and then the tall one stays straight up and down, and then it bends over after that. Like 5 minutes later, it does that. So that's what that suggests is I don't know how quickly I could find that, but to let this play here. But what that would suggest is that the surge came up and through, destroyed the structure of the nozzle of the vent, and then you have a whole bunch of loose stuff in there afterwards. And it's after that that the fountain then leans over. So whatever obstruction is happening in the vent, it's likely because this surge blasted it out and shattered the entire structure. Stuff starts crumbling in. Maybe some of that stuff manages to block the north vent somewhere down in there. It's hard to tell. Hard to know any of that stuff, right? But that was a major shift. Was the big once the big surge comes up, it destroys the whole structure. Now it's a free for all. What could actually happen up there? And then it happens to settle as an inclined fountain towards the camera, and then that's the end of the camera. Really, really fascinating sequence there. I'll pass back to you. Maybe I'll look for that video while you.
Okay. Here. All right, here we go from some on the ground shots. Phil, you kind of showed one of these right here from the cheeseburger. Just get an idea of, everybody was asking if you're over at Keanakekoi Overlook, that's what you were in right there.
Quite the spot. Yeah, quite the spot. And really, you could imagine if the winds were not being cooperative at that point, right? If the winds were blowing back towards Volcano House and it started doing some stuff like that, it would be probably not great. Probably pretty miserable experience to be caught in. So
we've been up there in a winter December or January episode where they closed off Keonekekoi Devastation Trail area because the winds were going in the wrong direction. Happens quick.
Yep, and you can get caught out there, so it's kind of justification for taking something like an N95 mask and some goggles of some kind of eye protection to protect yourself, because getting caught in that would be really rough.
Here's some more shots. Got this off of our Hawaii tracker from Wade Morales.
Thank you, Wade. Yeah, great shots. Wade's long-time contributor there.
Look how thick that is.
I know.
You can't even see through it.
That's the angle, the other angle that it presented. I mean, it was such a unique angle to be able to look in at all of the tephra that's really hardens, you know, as while it's coming down and getting to the camera. But you can still see the hot pieces in there if you look.
TT photography and videography. Great shot of just all the tephra blowing around up there. Hot, cooling, whatever, just so much. Great shot. Another one off of our Hawaii tracker.
And we really had a bunch of people come through there. Pretty awesome to have so many contributors coming through and sharing their experiences, you know. And for this type of eruption, you know, it's mostly just cool photos and stuff like that, but there are also, you know, when tephra was blowing on the roadway, we had people reporting first that way that this was happening. Why? Because they just drove through it and they recorded it and shared the video, right? All that kind of crowdsourcing of information. You know, for this eruption, been mostly cinematography and, you know, a bunch of videos and shorts, but sometimes there's some really important information in there that you get first this way.
There's our final shot in there. I thought I had some other. Where did I not put them in here? I have some cool shots. I mean, if I don't have them in here for tonight, I'll put them in tomorrow's. If you guys notice, we try to get as updates out during the week of what's happening up here. I don't see them in here. Is the last 5 images that I was able to capture from the V3 camera falling apart, being destroyed. I'll get them up to everybody. Check it out later. I also posted the link to Hawaii Tracker. You can see the images that I'll post tomorrow. And if you have some you'd like to share, you can put them on our Hawaii Tracker right there is the link. Phil, did you find our vid?
Yeah, I got it if you want to.
Sweet.
Swap it out here. All right. All right, so here is a video that I'm stealing from another geologist. I'll show you. I'll give him credit in a minute here. But there's a triple fountain earlier. And over here is that south vent when it first pops up. And so you can see there is a fountain pretty much vertical there at the very beginning, right immediately after it bursts, with a still double fountain. Oh, 2 mouses was confusing there. With the 2 fountains there from the north vent, still active at that very first moment. And you see this straight up there. It's almost landing to the right there, right? Camera is still very safe at this point in time. But then, so the big burst has already happened. The lava shooting up really high. Here's where it reaches its peak of 1,200 feet, 370 meters, right in there.
Hey, Phil, can you circle? Sorry, Phil, can you circle where that camera is about approximately?
I would guess it's off screen over here somewhere.
Yep. You're right. Yep.
Right
there you go.
Yeah. So there, you can see that right there, right at the moment where it becomes inclined. It goes from part of it's shooting up and the other part's trying to shoot sideways right there at the same moment. Right? And that's that moment right there where the fountain changes. And so that's likely after that big surge when something in the vent shifts to start obstructing a vent to cause it to become inclined. It happens instantly. Right? It's not like it's a change. It's just like something fell, something shifted, something moved. And that just changed the whole nozzle, so to speak. And it takes, another couple hours for the north vent to shut off, but it does eventually shut off too. And you have to wonder what extra lumps of material in your magma down in a hole in there. And the main jet coming out the south vent, what exactly blocked off the north vent? Hard to say. Interesting to think about. So I'll zoom it out here and give credit to Sean Wilsey who made this video with those captures there as well. Mahalo to the geologist crew out there. All right, we'll back to you.
Right on. Yeah, I saw Sean when he was here for AGU. He was here that week.
Quiet again.
Oh, I'm quiet again. Don't say nothing, Dane. How's that? We good?
Oh, really?
Yeah.
How's that? We back?
Good when you get a new wire.
Okay. How's that?
Better.
All right. We're better?
Yeah.
All right. Yeah, I met Sean during AGU this year.
Mm-hmm.
He was up here. Good guy. All right. That is our observations for the week. Shall we jump into Community Corner?
Sure.
Be short and sweet. Everything is about the holidays right now. So if you're into parades, they're everywhere. If you're into markets, they're everywhere. The park is fully open in all locations. Just go slow. There's a shot from up top, Mauna Kea, looking down at episode 38. Thought that was a good one right there off their cam. Like the lava viewing locations all around the caldera stay in bounds. Even up top of Mauna Kea. If you're down below, that's from Kīlauea. You can see that there. Nice shot there. And there is just a quick map of all the eyeballs show you. It doesn't matter where you're at around the caldera. You're pretty much going to see something with these types of episodes. Keep walking if you don't like where you're at. Welcome Center is open from 9 to 4:45. And go see our friends up there. The park rangers will give you all the information that you need for the park. It should be your first stop, they recommend. There it is. Look for the flag, hook a right. I need a new image of the HVO building. None of us have been in the park in a while to go over there. Last time I was in the park, we went straight over for the eruption. Parking is a madhouse. It was even worse, if you can actually believe it. The messages I was getting of those who were in the park said it was worse than episode 37, 36. How many rental cars do we have on this island? I can't imagine it being worse than this. Like I said, everything is open. All these trails are open. Check them out. The Kīlauea is still being repaired a little bit, but you shouldn't be affected too much. And Mauna Loa Road is open. Finally, this one is my favorite. It's a little bit of a drive up, but it gives you a beautiful view down for the episode. So if you get in there, you see the episode, you want something really cool to do, I recommend driving up top and looking at it from up top. It's a wonderful drive with an even better view. Exposure is a real thing. Stay hydrated in the park. Sunscreen, hat, and plenty of water. National Park would like to remind everybody that safety is your responsibility. It's on their webpage. And here we go. Yes, stay hydrated. Visitors to Hawaii Volcanoes National Park should bring their own drinking water during their visit. Kīlauea Visitor Center the water stations are unavailable.
I was waiting for the dog to run up.
Because there was so much last week. I have it for you. I thought I would give you this one first to warm you up.
The animation, yeah.
This was the same image from last week.
Right.
I just gave her a little life.
Yeah.
Here you go, ladies and gentlemen. Your friends have their water. One more time. Everybody take a drink of water. Bring your own water, even for your pets. There you go. There you go. Even your pets need water. Pack it up there. Stewardship at the summit's going on. Rainforest restoration. Get rid of the invasive species. You can help out Paul and Jane up there. There's information. Bring a hat, rain gear, day pack, snacks, water. Gloves and tools are provided. Ranger Park tours or the guided tours are going on. There's only one listed up there, but they may have others. Maybe you can talk somebody into it. Go into the Welcome Center and see what they've got going on for you. Tell Dean you really want something special. And this weekend it's finally here after weeks of waiting for it. The Dick Hirschberger event that's happening, A Walk in the Past with Dr. Thomas Jagger. This event could very well be his last presentation. It's at the Kahuku unit at 11 o'clock. Get there early, maybe even bring your own chair. Plan for a lot of people to be there and bring your camera. It's a wonderful storyteller, and it's been long awaited. Phil, you want to say something on this?
I think it's fantastic that he's been doing this for a long time. I don't know if it's been decades, maybe. I don't know. It's been a long time. He's been putting on this program, usually at the Volcano House, often in a Whitney vault. So it's interesting to see him doing it at Kahuku, right? Like, and think about Thomas Jagger himself would travel all over the place, and he dealt with Mauna Loa as much as he dealt with Kīlauea back in the day. So I think it's gonna be really interesting to see his take on being at that new location, how that inspires him or guides him in some way there. Yeah,
if you make it down there to the Kahuku unit, the 1868 flow is there. And you could drive up there and take a hike through that. It's a great thing to see. So there's a lot to do in the Kahuku unit. It's a beautiful part of the park, and it's often overlooked because everybody heads up top. Thank you, Phil. And Kau has the Taro Festival going on. Our Kau community has a lot of really good events. I just drove through Nalehu, and I noticed on Wednesday when I drove down there last week that the farmers market was packed. It was huge for a Wednesday. I was blown away. So I would expect no less this weekend at the Hertz Gymnasium complex from 11 to 4. They're going to have all kinds of prizes down there given away, but you got to be there to get them. And check that out if you're looking for something cool to do, if you're down there at the Kahuku unit. And you can sign up for our newsletter and our eruption notification email at hveri.org/donate. I'm sorry, hveri.org/subscribe. Stay informed with HVERI's new eruption alert system. Timely email when eruption and high fountains occur direct to your inbox. Dane and I try to get that out to you as soon as we think things are going to happen. So go ahead and Dane, did you put that on the screen for us?
I did. Yes,
Thank you. And next up is Dane.
I put it on the screen for you, and you said donate. Incredible. No, we'd like to thank everybody for tuning in today, but first like to thank County of Hawaii for helping provide the funding and the support for this program, as well as the county support for our digital resilience and youth development programs. Their support, as well as everybody that tunes in today, and the donations that you give us, is what keeps us going, what keeps us our ability to continue these broadcasts, as well as continue expanding as we're trying to do. So thank you everybody that donated there on the screen, and to all of our partners and collaborators seen here. And
you do have some donations.
Nope. Do take donations over on hveri.org/donate. That's where that one goes. And we do have a few donations that came through. Let me get those up. We had a $10 over from Raven. I appreciate that support, continued support. A $50 donation from Kim over on our donation platform. In YouTube, we don't have super chats. We have a fundraising through YouTube Giving that allows us to run that fundraiser there. So Norm with a $20 donation. And finally, Mark with a $50 donation coming through. I appreciate all the support there. We are doing the year fundraiser. Oh, sorry. Go ahead.
Mahalo, everyone. I just wanted to say mahalo as well.
Yep.
I would say we're at the tail end of our end of the year fundraiser. We're about $600 from our total goal of $5,000. So you still have time to donate.
Yep. Getting close.
Getting close.
Appreciate all the support that we've gotten. All right.
Here we go.
Do you have any more on back in there, Phil?
Yeah. You ready to keep going?
Right. Yep.
All right. So we'll start with our volcano watch next. Let me get my thing on the stage here. Oop. All right, here we go. So Volcano Watch this month is actually announcing Volcano Awareness Month next month. So besides going and asking Dean for your Nice Ranger program, you can also just wait till next month, and there's going to be a lot of stuff happening, both in the park and elsewhere, as USGS puts their effort out for outreach for volcano awareness. So that's what this article is basically saying here. It's announcing the month. Here is the calendar of events. We'll talk about this in more detail next week, I'm sure. But just know that you can go and find it on all of our channels and USGS channels, that this is now out there. It includes tables at Tsunami Museum, Science and Technology Museum, talk stories with geology, the field crew, the gas and hazards crew as well. It includes a couple of walks, one to Silver Banks, one to Devastation Trail. It includes the Disaster Preparedness Fair at Ocean View on the 24th there, as well as Onizuka Day, and a talk on the 75 earthquake at Kahuku, also over by Ocean View as well. All that happening on 24th. We're taking part in that Ocean View Disaster Prep Fair ourselves. In case you are an Ocean View viewer, let's track us down at that point in time. And then they're doing eruption update talks, kind of a similar talk, but all over the place. Here's one at Waikoloa. There's one at the KMC. There's one at the Imiloa. There is one at Kahuku, for example. So some of these are a little bit of repeats, but there's also talks from UH professors, talk story with all the field guys at the various libraries. And we have a talk from another UH professor, Dr. Liz Gallant, Volcanology 101. That should be a good one too. So just a heads up, a lot of these are going to fall on Thursdays next year. So we may have we'll discuss this among ourselves here and get back to you guys next week, but we may have some alterations to our regular broadcast schedule and some catch up to do in February if this eruption keeps its pace as it is now. So heads up there, go check it out for yourself. And if your person needs to make those plans, then there they are. We have both the Volcano Watch as well as a post itself that has descriptions of each event with the speakers and locations and all that stuff as well. So more on that next week. But just to share, that's another piece of our community outreach here. So let's go to our monitoring now, and let's see how quickly we can get through this, because I know we're at our back end already. But first, we'll go through our text updates starting last week on Friday. And at that point, what I wanted to point out was that is when we still had spattering events, large flames, tremor bursts, all that happening with glow. This is right after our update last week, kind of where we'll pick it up. And then on a Saturday update, they note precursory eruptions began yesterday, and episode 38 is about to begin. They know all the details of the overflows, and basically at this point, 8:25 a.m., they're only 20 minutes out from when the fountains would actually start. So perhaps by the time someone might have read this, they might have looked over and seen, oh, it actually did actually just start. So interesting to note that. So the next one I'll pull up is the volcanic activity notice, the VAN, issued at 8:48. You see they were ready to go. And noting the onset at 8:45. And the overflows and all that, right? So this is 3 minutes in. There's not much else to say at that point in time. There's also an aviation notice put out at the same time, the VONA, as is standard practice now. So we then actually get a status report at 10:41 a.m. partway through. They noted that after the onset of fountains, that there was this rare event of a triple fountain with 3 roughly equal sized 500-foot, 150-meter high fountains, with 2 from the north vent and 1 from the south vent. This triple fountain is an extremely rare event, and it's the first time during this eruption it has been observed. Okay, so that's that interim update, 10:41. So the next one we get is going to be the ending of the eruption, van activity notice, 9:08 p.m., noting 8:52 p.m. abrupt end after 12 hours of fountaining. They note the fountains reaching up to 1,000 to 1,200 feet, depending whether it's inclined or upright there. The south vent fountains, 370 meters during episode 38, dropping down substantially before the end of the eruption there. They note here some eruption rates, but I have some suspicions this may not be quite right. This value, 12 million cubic meters, we see bumped up to 12.6 in the update that comes after this. But we'll revisit this here as well. Triple fountains are noted here. Here they say the highest peak. So here, by 9:40 a.m., the south vent fountain grew to about twice as high as the north vent fountains. The highest peak or instantaneous effusion rate of 1,300 cubic yards per second, or 1,000 cubic meters per second, occurred just before 10 a.m. when a south vent exploded. That's their words, not mine. I would call it something different myself, right? I don't think there's any kind of, yeah. Anyways, right, we could discuss this. It's not worth going into this tangent now. When do volcanoes explode and when don't they? What do you call it? When do you call it that? All right, so the enlarged south vent produced an inclined fountain over 1,000 meters tall that sprayed the south wall. Hot pumice and molten pattern from this fountain destroyed HVO's V3 streaming camera site. They covered up to 60% of the crater floor. Still expecting to see more movement and incandescence after the update was released. It's paired with the aviation notice as well. Same information. And then moving forward to Monday's update, they note there that glow was being observed and from cracks near the north vent. We also know that there's glow from other cracks further on that southern wall. They note that creeping spatter-fed flows in the south of the south vent with incandescent spots. Those are those cracks I was discussing there. The largest flow, that center one on the crater floor, could still be seen creeping on time-lapse movies this morning. So that's pretty cool. They don't usually say the USGS refer to their own time-lapse movies, but they must be making their time-lapse movies and watching them every day like we are as well. At least one incandescent rockfall from the V3 camera hill perched on the south wall of Hawaiian. Right, we saw that little landslide area. I wonder if that was the same thing, but in any case, that is the area. So that's interesting things from Monday's update. I'll just jump ahead now to today's update, right, where we have basically the pause, moderate glow continuing, onsets now expected between December 20th and 30th. Does that mean the 25th? Who knows? We'll see if we get a Christmas eruption or not. But there you have it there. Everything's back to normal range, but I think it's interesting if we come back to the recap of episode 38 here. We have a lot of this information. We do have 12.6 million cubic meters reported here in total. And we're also seeing this rate of 190 cubic meters per second reported in episode 38. 250 cubic yards, 190 per second. Now, I'm a little suspicious of this. Let me tell you why. I'm going to pull back the Friday update, and let's go to the recap of episode 37. Had an average rate of about 250 at 190. Suspiciously identical there. Right, so I wonder if there was just someone forgot to update it, or there was a copy and paste edit, something like that happened. And the reason I say that is if we come to our own discharge rates, jumping ahead of here, I get 190 for 37, or other ones have been on point. I actually get somewhere closer to 250, 275 for 38, so a little bit higher there. So we're curious if that'll be changed at some point or not. But to back it up here, we had a 9-ish 10-day pause there. So there is that length of pause, a little bit shorter than we're used to having recently. So that's that shorter interval between, followed by a return to the higher fountains, higher than 1,000 feet, which we did not get in our last episode. That, interestingly, only the north vent was active that one. The south vent did not contribute that time, right? As we talk about our vent dynamics and how things change and all that, the blockages, what have you. an interesting twist there as well. But so we're back in this population of these high fountains. Looks like we're still in that character of phase. Our volume we mentioned was just a little bit lower. This one was 13 million cubic meters. This one's 12.6. This one came out over 8.5 days. This one came out over 1/2 a day. So clearly, that's where you see that much, much higher effusion rate. Let me show you back right here's episode 3, and here is 38. Much different as far as how fast the lava is coming out. And of course, to get to that, we need to have a combination of the volume and duration. And duration, we actually had a little bit longer than we've had for a little while here. And perhaps that has something to do with the fact that the north vent did shut off after 3 hours. We had another 9 hours. 3/4 of this episode was actually the south vent only. And maybe since we didn't have both vents putting out that high volume together, that allowed it to last a little bit longer because it just took longer to come out of the one hole instead of coming out of 2 holes at the same time. That's a logical interpretation to me. Of course, curious to hear what else the USGS might be able to add as far as information to this too. So those are our data updates. I think I'll just really quickly run through our other monitor information. We can see the crater elevation values is blown out by some noise here. We have our episode 38 deflation with some distant earthquake signals embedded here and here. This one was Alaska. This one was Japan. But resuming our pattern, while the green line on the rift zone would show a little bit of wiggle here, but nothing major, and this resumed its normal deflationary trend in the green there. Earthquake counts are really just zoomed way in. There was 1 magnitude 3 earthquake, which shows this big spike. Otherwise, we're right around our average background per day. There's a magnitude 3 on the south flank. Pretty steady deep, pretty steady shallow otherwise. Not much else to highlight there. Distribution on the map, right? This east rift and southwest rift bounding the south flank, which wants to move oceanwards. We saw last week the 4.6 over here. And all these blocks of land are all stacked on each other, leaning on each other, kind of connected, right? But so when this one moved, it probably has a domino effect where you have other pieces of the flank wanting to move as well. So I would probably categorize this earthquake as more of that adjustment ongoing still. So for the last month, we're also showing noise here. This is because a VOG's blowing in front of the laser, and so the laser thinks that the ground is suddenly right in front of it. It's just telling us the elevation of the laser more likely up here. So we can't tell exactly how much thickness we got of lava in this last episode, but it looks like it's similar, like a couple meters maybe, at the location where the laser is pointed at least. Here's our whole last month of ground tilt at the summit in blue and rift zone in green. And you can see the 4.6 from last week that happened right after episode 37 ended, also shown on here. Similar pattern at Sand Hill. There's not really anything I need to point out differently there. Or in our earthquakes per day over the last month, we're still hovering around our background there. There's our 4.6 last week, followed by a 3.0 this week. So you can see very similar depth range and geological setting there. So here's the last 3 months once again, a little bit shorter pause interval between 37 and 38, and a bigger drop, 33 microradians was a reported value here for 38 too. So we'll have a long recovery, and it all depends on the rate of how quickly this comes up, whether we hit December 20th or December 30th or somewhere more in the middle or even beyond, or who knows exactly. And there's that whole pattern for the whole almost year-long eruption now. And you can see that there we are. It's just fitting right in. There's variations, but we won't dig into those at this moment in time. It's still doing its thing. Lava depth for the past year building up. You can see there. You can see we're actually close. So let's call it 495. We might have started at 410, so 85 meters there. 250-ish feet, more or less. Just my back of the envelope math here of where the laser is pointing, how thick the ground has gotten there. Earthquakes over the past year. Right here's the biggest spike in the graph was the lead up to this eruption back in early December of last year. And since then, we're able to release much of that pressure. GPS is still showing this accordion stretching out, leading up to an episode, and then contracting between, and similar pattern here. And the total range of 38's contraction was about 15 centimeters, about 6 inches in 12 hours. The ground sagged back together, and then over the next couple of weeks, it'll stretch back out those 6 inches. Pretty amazing that it can move that much, right? Imagine if you had your house anywhere on there, like what you'd have to do to, right? That's, just think of it that way, like how much the ground is actually moving. If there was infrastructure, that'd be a problem. And Pu'u'o, we don't have any GPS data coming in, but we've seen from the tilt that everything looks calm there still. So those are our signals. I just want to touch a couple final things here. We have another INSAR image that spans from the Mountains Project, that spans from the 30th to just before the eruption, episode 38 starts in the morning of the 6th. So this is picking up just the inflation signal. It's showing us here is a center of that magma body where it's pushing upwards on the ground the most. It's underneath this east side of the inner crater. You can see that's the direction, blue to green to pink, blue to green to pink, towards the radar, towards the satellite. Ground is rising up here just before it popped. In comparison to last week, it's the opposite direction, right? Where that one we actually caught from the 24th to the 30th. We caught the last episode 37 in between there. And so we actually caught a deflating opposite pattern. So everything is as it should be here. Nothing really significantly changed. Okay, going to our recent earthquakes. Looks like my map reset itself. So let me fix it with my about 50 clicks here to get this the way I like it to look, to see the whole island, to see it with a satellite background, to have the earthquakes plotted by depth, to remove all the other symbols on a map that are not earthquakes because they just get in the way of seeing where the earthquakes are, to be honest. And there's no way to turn them all off at once. So I've got to go through here and click everything, recent flows off. And there we have it. Oh, and now I need to go to the time period. And rather than 2 weeks, I want just the last week. So if you've never used this website before, you know, manipulate data is a good way to do it. There is how. So here is finally the map that I would like to show you. Right there, right? So reds are the shallowers, blues are the deepers. Starting deep, the Pahala hotspot zone is still feeding from down here. That's kind of normal background at this point, even though it's a very high, interesting, curious background that's been ongoing for years now. We have our blues and greens over here as settling events underneath the north side of the island. They can happen anywhere. We have an event here, 2.1 on the west flank of Mauna Loa. Slight adjustment. There's known faults in this area that do move like this once in a while, no big deal. We have Kīlaueas over here on the right, and so this includes that magnitude 3 and several aftershocks we can look at in a minute here. And then we also have summit events and population between Mauna Loa and Kīlauea in this in-between zone, which we've talked about for years now, even before the Mauna Loa eruption, how there was this influence of the volcanoes on each other, especially in this area right here. So as one pressure rises, it pushes on the other. They're both filling with magma and both having ground movements to adjust, and so that's where they can have some more frequent adjustments through these earthquakes. So that's the big map colored by depth, and I like to also show this one where we plot them by magnitude. So there is our largest 3.6 of the last week, which is a deep Pahala earthquake 18 miles down. We also have a 3.2 off Pu'uku, 65 miles down, way down in the mantle. That's a curious, weird one. It's not, you can't even call that one settling of the island. That's way below the structure of the island and the tectonic plate. Yeah, so it's interesting. That one's interesting. And then the next one is a 3.0 here in Volcano. It's two red ones. This one's colored by time. So these are the two most recent ones that we have. This one is 2.0 that occurred here. It looks like about an hour ago. And this one, 2.2, very shallow as well in between here too. So zooming into that sequence on the south flank. right there. So you have a 3, 2.2, and 1.9. Those are basically the sequence of events right there. And so those are the earthquakes we've seen in the last week, and that's all we need to share with you guys this week of what surrounds episode 38. All right, guys.
Right.
Shortest back half I could make.
Got a whole bunch of stuff. We did have one more donation come through. Wanted to shout out Wired for Stereo with a $5 donation. Appreciate that one there. And I don't see any questions that we had that you didn't cover. Yep. Some of the questions were asked and then answered type of thing immediately afterwards.
Fantastic. Like reading minds over here without reading chats.
Right. It's good.
Yep. And yeah, we be back next week with our last one of the year.
Yeah, next week is our last one of 2025. Crazy.
Right. Take a little break, and we'll be posting updates on Hawaii Tracker and over on the social medias, but probably won't be doing the live stream unless something unexpected happens that's outside the caldera, really.
Yeah, exactly. Yeah, so it turns out that Christmas falls on a Thursday, New Year's falls on a Thursday, so we're taking those 2 weeks off. We'll do the week before Christmas, we'll do the week after New Year's, but not those 2 weeks in between there. So that's another schedule heads up for you guys there.
Yep.
We're going to have a lot of catching up to do starting next year, aren't we? This thing keeps up.
Probably.
Oh, yeah.
It's like, it'll feel like we missed 15 episodes by then.
And I just put in our we even though we won't be doing our live streams, we will put out an eruption notification.
Yep.
So I went ahead and put that in there. If you haven't signed up for it, the link is in the chat right now. Subscribe.
All right.
That's it.
All right. Thank you, everybody, for tuning in. And I think we'll be back next week, Thursday, 5 p.m. Hawaii Standard Time, yeah?
Yep, exactly, yeah. So we'll be back, and yeah, with some schedule changes coming up. And wishing everyone happy holidays already. Yeah? I was going to say, I thought I've been trying to squeeze in some time to celebrate Mauna Loa's eruption anniversary here. It's kind of come and gone in the last couple of weeks, but there's been so much going on. We've actually had, we were on a pace where we had an episode of Kīlauea, then a couple of weeks off, then another episode, a couple of weeks off, and we actually just had 1 week off this last time because of the short duration. So I kind of messed up
everything off. Yeah,
the programming I had lined up for you guys. At this point, I wonder if there's going to be enough time to really do that next week, because what I would like to do is a year in review of this eruption we've had going on now. It's going to be about the 1 year anniversary, right? So we do know Volcano Awareness Month is going to have talks on Mauna Loa as well. Maybe we'll punt Mauna Loa to then we're going to have the USGS contribute, and we can piggyback off of them. So a little bit more of the schedule. But if you have any giant dying requests, throw it out there too.
Yeah, because we are co-hosting with Ocean View, Resilience Hub, Civil Defense, NPS, as well as USGS-HVO for the preparedness fair that's going on in Ocean View. It might not be bad to just move our Mauna Loa
right to then, and then we can release some media about it and turn it into promotions of the event at the same time.
Yeah. What's really nice is that we get them to actually show us some nice graphs on Mauna Loa, which we don't get on a public website. Right? And then we can use those to explain what's going on and to understand what's better happening. So we don't have that now. We just have the actual date anniversary. So maybe we'll wait for some more data to come out.
Yeah.
Since there's so much going on, we have to actually force to choose, or we're going to keep going for 2 or 3 hours every time here to just try to get through the end of the year.
Yep.
All right. I've talked enough.
All right.
Thank you, guys.
Us.
All right.
Thank you all you guys who are all watching us here. If you haven't already liked and subscribed, if you're still watching 2 hours in, then what are you doing? Come on now. We love you guys. Happy holidays.
Happy holidays.
All right. From our nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute, I'm Philip Ong for Louis Torrey and Dane DuPont. Aloha, everyone. Until next week.